Hi everyone and welcome back to Maths and Physics with Mr. Simons, where we simplify maths and physics and we get you exam ready. Alright, so today's classwork lesson on algebraic expression deals with the second variation of the 7 that we're supposed to teach. And this is products and differences of squares. So when I say differences of squares, 16 is 4 times 4, which would be the perfect two sides of a square. X squared times x squared would give me x4. 9 would be 3 times 3. Y squared simply y times y. So you should see there, for this answer, I multiplied everything with itself. So that is basically all sides of a square are equal. But let's look at it further. Right, the difference of squares when you have a set of two brackets with two terms in it. So you see there, I've got two terms in each bracket. The terms in both brackets are the same, so there you see I have 4x squared, 4x squared, 3y, 3y, m, 3x, m, 3x, 5, 5. Except the signs are different, so they're positive, they're negative, positive. Then we say we're dealing with difference of squares. Now the reason why I'm going through it piece by piece like this is because it has a specific way we're going to multiply it out or find the products. So for difference of squares, we see that the terms are the same in both brackets, but the only thing that's changed is the signs. We will ensure that we multiply only the first term with the first term and the last term with the last term. Very important. I hope you've got that. So if the terms in the brackets are the same, but the signs are different, positive and negative, we will ensure that we only multiply first term with first term and last term with last term. So if you look here, I've got 4x squared and 4x squared, exactly the same. 3y and 3y, exactly the same, but that one is positive and this one's negative. So therefore, for multiplication, 4 times 4, x squared times x squared. Right? Positive times negative gives me negative. 3 times 3, y times y. 4 times 4 would give me 16. X squared times x squared, when we multiply and the bases are the same, we add the exponent, so 2 plus 2 gives me 4. Right? Negative, we carry down. 3 times 3, we assume you know is 9. Y times y gives me y squared. So therefore, that becomes 16x4 minus 9y squared. Right? Now, if you look at the second one, I have m to the power 3x. They have m to the power 3x. I have negative 5 and positive 5, so the terms are the same, but the signs are different. So again, m3x times m3x means we're going to add the exponents, 3 to the power x, or 3x plus 3x, not 3 to the power x. Negative times positive gives me negative 5 times 5. So 3x plus 3x would give me 6x. 5 times 5 would then give me 25. And there we found the difference of squares. Right? Now these are basics what we teach in class, just to show you what we do. So be very careful. I'm doing classwork and then I'm going to do exam work. The classwork is the work that you need to know, but what we do in class is not necessarily what we test in exam. So the next two problems, I'm just going to show you how we make these problems a little bit more complex, trying to catch you out in exam, but we will do a whole series of exam questions. Right? So yeah, on Maths and Physics with Mr. Simons, we will ensure that you see the classwork and the exam work on this YouTube channel. Right, so difference of squares. So number 3, they gave you 3a minus b times 3a plus b times 9a squared plus b squared. So first we should see 3a and 3a are the same. b and b are the same, but the one is negative and the other one is positive. So therefore, 3a times 3a, negative times positive stays negative, b times b, and that simply stays 9a squared plus ba squared. 3 times 3 is 9, a times a gives me a squared. That stays negative, b times b then gives me b squared. 9a squared plus b squared is then simply carried down. Now again, take note, Now I have 9a squared and 9a squared, they're the same. I have p squared and p squared, they're the same. But the one is negative and the other one is positive. Therefore, multiply first term with first term and last term with last term. So 9 times 9, which is 81. A squared times a squared, which is a4. Negative times positive, which is negative. B squared times B squared, which then gives me P to the power 4. So that's the first way we change the question, trying to catch you out. Then number 4, see we have x minus 3 times x squared plus 3 and then x plus 3. So we assume if you look carefully, you can see x minus 3 and x plus 3 are basically two brackets that are the same, just with different signs. So I can use these two to create a difference of squares problem. So I'm going to rewrite it, x minus 3, x plus 3, and I leave x squared plus 9 at the end. So now I have a similar problem to what you see in number 3. So x times x squared minus 3 times positive 3 gives me negative 9. And then we carry x squared plus 9 down. Again, x squared and x squared the same, 9 and 9 the same. So x squared times x squared would give me x4, negative times positive, and negative 9 times 9, 81. So I hope you follow. The key concept that I want you to carry and understand is that we do classwork, but we have to practice the more complex exam questions, right? Which I'm going to do a whole series of, right? It's up to you whether you go watch them and make sure you don't get caught out. But the sooner you come to understand how to find your products, the easier it will become going to grade 11 and 12, because this question is going to form part basically of everything we're going to do in maths. There will always be some form of multiplication or division, addition or subtraction, right? With practice, remember, you can accomplish anything in maths. Maths is a practice subject. The more we practice, the better we become. God bless. Bye.